forward. So for the last little bit, I had you guys work on systems of equations through graphing, elimination, and substitution, right? So do a little bit of practice, make sure you're good. I will post answers for you guys so you can check your answers. I know some of you are getting crazy answers like Michael, you said 12 over 29. I think you got it, was it 11 over 21 over there, Cooper? For one of them. That may feel awkward to you, but that's okay. Those are good answers. And I'm going to show you a new trick tomorrow, how to do that 100% with a graphing calculator and matrices. Which you've done in Algebra 2, but I'm going to show you a slightly different way that Shasta College wants you to know, called row reduced echelon form. We'll talk about that tomorrow. So what we're going to talk about today is we're going to leave linear. So everything that we've done up till today has all been about things that are linear in nature, okay? It's just dealing with things that are that way. So today, what I wanted to do is start talking about quadratics, which means anything that has like an x squared in it, right? And so it turns out for this is a pretty significant lecture because I'm going to throw some stuff in there. Some of you had me in Algebra 2, and I think we really stressed some of these points when I had you. A lot of you did not have me, but I'm pretty sure your teacher did. So we're going to look at a variety of methods to solve those quadratics, and I'm going to call that prereq number 3. This is the first one I'm really kind of slowing down. I'm going to spend some significant time on it, and we're just going to go line by line and make sure everybody understands it, because this is something you're probably a little bit less obviously familiar with, at least in stages, okay? So what we're going to do right now is we're going to look at quadratics, okay? So how do you solve a quadratic? So if someone handed you this problem right here and said, solve that problem, how would I go about finding the value of x? Now, hopefully everybody understands a couple little things about that this should be a parabola, right? Should this parabola open up or should it open down? And how do you know? If the leading coefficient is positive, it should be opening up. It should be like a smiling looking parabola. Remember, if that was negative, it would open down. Anybody remember anything else about it? What does that 8 do? Yeah, I wish it was. I wish it was a vertex. It'd be nicer, but it's where it crosses the y-axis. If I plugged in 0 for x, I get 0, 0, and 8. That'd be where it crosses the y-axis. So it turns out there's a few methods. So one of those methods is graphing. So we're going to look at not much on graphing because it's not really the optimal way to solve these, but it is valid. So if you were going to do this, one of the things that you were trained to do back in the day was to take a look at the axis of symmetry. You guys remember opposite b over 2a? It was actually part of the quadratic formula, which we'll look at in a minute. But that is the place where that vertex is. So if we were to plug in the number 3 into the original problem, what do you get if you plug in 3 into the original problem? Would look like the following. And when I did all that, I got 3 squared, 6 times 3, 8. Looks like I got -1. Guys, that's the vertex. So if that's the case, that 3, -1 is the vertex, and it opens up like this. And some of you probably are aware, how many of you guys have heard of the 1, 3, 5 pattern in parabolas? Okay, most of you have heard of that. If the leading coefficient is 1, you just go over 1 up 1, over 1 up 3. Well, the nice thing is if you go over 1 up 1, I just got the spot 5 right here. No, I didn't. I got 4 right there, and I got 2 right there. Piece of cake. So where does this graph cross the x-axis? Is that x equals 2 and x equals 4. Now, that's awesome. Those are good answers. And you can write it this way. That's a valid way of answering that. There's a list of answers, they're 2 and 4. Or you could say x equals 2 or x equals 4. Those are good. Now, I like graphing them, but that takes a long time. Anybody think of a better method for that? What would be a better way to answer this? Anybody remember? Quadratic formula is good, but what I was going to go ahead and go with is method 1. I'm going to call it, by the way, this is like method 1, I suppose. I should call this one method 2, would be factoring. See, instead of answering the problem that way, we could ask the question, give me two numbers whose product is 8, but whose sum is -6. What would they be? Whose product is +8, but whose sum is -6. -2 and -4. And then you could look at this, and the zero product property says, what's the only number that I could plug in for x that's going to make that happen would be 2. And the only one that's going to happen there would be 4. And so you get exactly the same answer that we got the other way, but far easier. How about this guy right here? X squared minus 30 equals 13x. Now that problem, obviously I did something to it. Notice I didn't make it equal to 0, but what are we going to do then? If it's not explicitly equal to 0, what's your job? Make it equal to 0. So let's pop that thing across. Now something happened that's a little bit different this time. I need a product of -30 and a sum of -13. Now this is one that's going to get a lot of you. Think through what numbers would have a product of -30 and a sum of -13. -15 and 2. That's exactly right. Now, I don't know if you caught it, but I was trying to fool you. I was hoping some of you say 10 and 3 would have a product of 30 and 10 and 3 would have a sum of 13. Why is that not the right answer this time? Because what did one of them have to be according to this is at least one of them had to be negative, so it would blow that out. So what are the two answers? Careful. What value makes this one go to 0? +15, -2. Okay, now remember when you have that in factored form, you're always going to switch that up. Now, what I have noticed is most of you guys are probably pretty darn good at these problems. And then all of a sudden, when someone is mean and they add a leading coefficient, does that make your world a little bit harder? Now, it's probably been, oh goodness, March 12th since you've done anything like that, since you probably didn't do much factoring since the day Algebra 2 died. You know, with Rona when it came along and reared its ugly little head. But you guys have a whole lot of ways to do this. So do any of you guys like to make the big box thing and kind of fill that out? And some of you do like it, and I can totally honor that. But sometimes we can just do what's called guess and check. What are the only two numbers you could think of that would have a product of 3x squared? It would have to be a 1 and a 3, wouldn't it? So the only way, if this problem is factorable, is that way. It's the only thing I can do. And then I look through and, you know, it's either going to be, how could I get a 12? Well, it's a 1 and a 12, a 2 and a 6, or what's left? 4 and a 3. Now, for me personally, I always go inside out. And so I cannot put a 3 here. And the reason I can't put a 3 here is you see how this has a 3? That would mean they have a common factor, and this thing doesn't have one. So I'm just going to try a 3 and a 4. Now check it out. If I have a 9 here and a 4 here, can I make a 9 and a 4 into a 5? Yes, I can. How can I make a 9 and a 4 into a 5? Positive on that one, negative on that one, and that leaves me with the answers of -3 and +4/3. Now, if you guys like the box and all that stuff, you may feel free to do so. But I can tell you honestly, guess and check, the further you go in math is the one that I would like to see you do more than the other. So your turn, see if you can solve this one by factoring. I know you guys have factored a lot in your background because you've done a lot of classes where they make you do that. So I'm not going to spend a long time on factoring today. See if you guys can factor that problem and give you a moment, see if you can come up with what works for that one. It does factor though. Did anybody come up with good factors? 5x. Say it again. Yes, it is. But what's going to go here? 3 on this one and a 5 on that one, right? Now, what I can see on the outside is a 25 and a 6. How can a 25 and a 6 make negative 19? The negative on that 25 and a positive on that. So the two answers are what? That looks like this one would be, this is again, it's been a while since you've done this, so I hope you guys remember that little trick. If you see the 3 and the 5 in this way, this one would be negative 3/5. I hope I'm not going too quick on that. You've done this before a few times, but I know it's been a while. You know, you got to get back on that bike and ride it again. What would this one be? What was that? Positive, remember it's positive 5/2. So those are good ways to solve that. But you know what? The bummer is quadratics don't always have nice answers, right? So here's what I am saying to you guys. My favorite way of solving a quadratic is that one. So if you look at a problem, the first thing you want to do, take out your tool. You know, like when you work on a car, you take out your tools and you go, which tool is the right tool for this job? This is the best one, but it doesn't always work, right? You guys should know that. It doesn't always work. So check out to see first if this is a good tool or not. The second tool is one that a lot of you guys, I can tell you from experience, this will look almost brand new to you. I don't know why it's new because I know we do it, but people forget about it. And it's what I'm calling method 3. So graphing, factoring, method 3 is this dude right here. Let's see, I'm going to call this problem 5. And every year I have people where I set this problem up and it's ready to go. And it's like, hey, let's go solve this. There's something very specific that I did that is supposed to make your life better. And every year I'll have a test with a problem like this or a quiz. And the first thing people do is they distribute. If you divided both sides by 2, anybody have an idea of something I could do that would be really, really fast right now? Could I take a square root of both sides? And all of a sudden I have very simply that x minus 4 is the square root of 11/2. Now there's something that I need to add in there, and I don't know if you guys remember that. But remember, from very basic stuff, if I told you x squared is 49, how many answers are there to that problem? Because not only is 7 squared 49, negative 7 squared is also 49. So we need a plus or minus. What is the only thing left to finish that problem? Move the 4. That's it. X is 4 plus or minus root 11/2, and we're done with that problem. That is super slick. If somebody hands you a square, smile and use it every time. By the way, on Wednesday, I'm going to ask you to do a problem like that, and most of you are probably going to foil that thing out and just destroy. I've set up the thing for you to hit, and you just knock it off the tee and work on it. So similarly, let's see, what would this first step be to that problem? Again, I set it up for you really nice and easy. What's the first thing you should do since 2x plus 5 as a quantity is getting squared? Step number 1, let's just root that sucker, right? Now, careful about that. I wrote 14, and I meant to be nice to you. You like 144 better? What's that going to be equal to then? Careful. Plus or minus on that 12. Good. So now for me, what I do is I set one of them equal to the positive and one of them equal to the negative on that 12 because that's going to make it faster to complete that story. So again, it's really, really nice if someone is kind to you and just sets it up on like a little tee and you just hit a nice little quick shot off of that thing and it's easy peasy. So you guys doing all right? So graphing, how's graphing? It works, but it's slow, right? Factoring. I love factoring. It's by far the fastest method, but it doesn't always work. This one's okay, but honestly, this is pretty rare. You just kind of have to be aware that sometimes it's there. So here comes method 4, and this method 4 is when they didn't actually set it up for you, okay? They just didn't make it so nice for you. So you're going to look in method 4 when someone says this one. Now, step number 1, should I factor it? Can you guys come up with two numbers whose product is 1, but whose sum is -8? Two numbers whose product is 1. By the way, the list is short on that one. 1 and 1 is all I got, right? They don't have a sum of -8, so I'm kind of screwed. I can't do anything with that. So this method right here, let's see if you guys can remember this one. This is honestly my favorite way of solving a problem that is non-factorable. Oh, let's see if you remember it. You take this dude right here, you cut it in half. You guys remember the next part? Almost. You cut it in half, and then you square it. So guys, what is half of -8? -4. Square that, you get 16. Now, because of that, this has now turned into a perfectly factorable little thing that is x minus 4 times x minus 4. And all of a sudden, I have method 3 again. Because what can I do since x minus 4 is being perfectly squared? I can just take a root, right? And as soon as I take a root, the only thing left to move is my happy little 4, right? As soon as I move that 4 across, I have completed the square. So your turn. You guys, I would like you to solve that one by this method. Okay, try it. See if you can remember how to do that. Move that 7 so you can then complete that square. Good. D, you already got it? Nice. D, what did you put right here? 4. Perfect. You cut -4 in half, you got -2. You squared, you got 4. Big deal. Boom. 4 and 4, right? So, what does that make this thing right here? What is this? What is x squared minus 4x plus 4? What is that? Perfect square being what perfect square? X minus 2. That's equal to 11. Take the square root of both sides, and then what's the only last little piece to actually do is move the term 2. Get that 2 out of there. See, I have a lot of people say, completing the square is really hard. I hate completing the square. It's actually a really, really nice way to do these problems. Now, I'm not going to beat this horse for too long. I wanted to do 2 problems that are unkind. You guys like fractions? Sure you do. You love fractions. Fractions are your friend. Let's start with the F word, right? They're friends. Okay, so moving on. We're going to go ahead and do 2 problems. By the way, watch this first one very carefully because the second one you have to do on your own, and I will give you longer on it because it's harder. Okay, what's wrong with this problem? What jumps out of these? You says, wait, this is going to be a harder question to deal with. Why can't I just go cut the 5 in half? There's a stupid 2 in front. Dang it. So what do? Divide by 2. No big deal. Now, again, I know erroneously some of you guys have been led down this bad path that says fractions are hard. No, they're not. They're not hard at all. So, hey, if there was half a cookie and you cut it in half, what would you get? You'd get a quarter, right? So, guys, you know what half of 5 halves is? It's 5 quarters. No big deal. So I'm going to take half of this, 5 halves, I'm going to get 5 quarters, and I'm going to square that. I'm going to write that right here so you can think about that. What is 5 quarters squared? Thank you. So I'm going to add 25/16 to both sides. Now, what that means is you have just created that, and I don't have to think hard about that because I can guarantee you the answer to that first question always goes right there. What's half of 5 halves? It's 5 quarters. It goes right there. Why is it negative? Because that one is negative. Now over here, if I wanted, why did I write quarters there? That's supposed to be 16ths. I'm better. So if I take this 8/16, you guys okay calling that 8/16? 8/16. With that one, I got 33/16. Now, oh my gosh, this is so hard, isn't it? No, it's not. What do we need to do next? I need to take a root. But something really, really, really cool happens right here. When I take the square root of this side, what's going to happen is I'm going to get root 33 over what? Careful about this. 4. Is that on accident that this has exactly the same denominator as the other side? No, it naturally does that. So you will be lied to that fractions are really, really hard. They're not. This thing naturally does that for you. If you follow the rules, it just works. So your turn, you're going to do one of these. Oh, this isn't so bad. 5x squared minus 8x plus 3 is 0. Your turn. See if you guys can do one of those problems where you have to tangle with the beast completely. And I will give you more time on this one because it's a little tougher, okay? You're going to have some fractions. And by the way, 2 ways, it's half of 8 fifths. Some say half of 8 fifths is 8 tenths. Yeah. What's half of 8? 4. And half of 8 fifths is 4 fifths. Okay. By the way, if you said 8 tenths, you're good though. Same thing. It reduces. No big deal. All right, half of 8 fifths is 4 fifths, right? Square it, 16/25. Stephanie, what's going to go right in there? What's that? X, is it a plus or a minus? It's a minus. Half of 8/5 was 4/5. Ooh, what's that equal to? Dang, that's not so happy, is it? What is negative 3/5 and 16/25? So you guys figure that out yet? It's 1/25. By the way, if you have one of these handy dandy little calculators right here, I don't know if you know you can do this, but if you type negative 3/5 plus 16/25, if you hit math enter, it'll tell you your answer as a nice simple fraction, kind of do some of that work for you. Now, I was mean, but do you notice something? What happens when I take the square root of this? It's perfect, isn't it? Oh, hey, you know what that tells you? If you ever take the square root and it's perfect, it means you could have solved this problem by factoring instead. Oh, shoot. Oh, that was 4/5, wasn't it? So what are my two answers? If I add 4/5 to 1/5, what do I get? 1. And what about if I have negative 1/5 and I add 4/5? I think it's 3/5, isn't it? So that's a good answer, and that totally works just fine, and life is good. If you look at this, now I really want you to honestly follow that process. Was that many steps? There's one more method. What's the last method? So we graph it. How's graphing? Graphing's okay, but it takes a long time, and sometimes, what if the answers are ugly? You're not going to see it, right? Second method is factoring. How's factoring? I love factoring, but does it always work? No, in fact, this problem right here, factoring will fail because it's irrational, right? So then we go to completing the square. What's the last version of a way that you guys know? And I know you've done this because somebody even said it earlier. There's one more way to solve this. Oh, goodness, you guys are so quiet. Is it the mask? Okay, well, shoot. I don't know. So what would happen? Let me see if you guys can just go with me through this thing. Let's see if we can just do this. I'm going to set this equal to 0. Can we complete the square on that one? Can I complete the square on that? What's the first thing you got to get rid of? Don't we need to get rid of A? Isn't that what you guys did? Whatever number is sitting in front, let's divide by it. Okay. What's the next step? After you got rid of A, we did that. What do we do to this middle term right here? What do we do to it? We cut it in half. And you know what half of B over A is? It's B over 2A. But we got to square that, don't we? So what happens if you took that and you squared it? What's B squared is B squared. What's 2A if you square 2A? Careful, what's 2A times 2A? 4A squared. And we got to be fair, and we got to put that together. So now this thing right here is this. I don't know if you guys are catching what's actually coming at you right now. Do you notice anything that's starting to, like, a little remembrance showing up? Oh, hey, you know what? In this last problem, we needed to make a common denominator. So I need to give this one a 4 and an A to make it a common denominator. And I got a B squared minus 4AC, B squared and a 4AC. Uh-oh. What is popping out of this thing, ladies and gentlemen? What are we getting? You're getting the quadratic formula. We take the square root of both sides. But what is the square root of 4a squared? The square root of 4a squared is? No. The square root of 4, a squared, a, 2a. And all of a sudden, there's our happy little quadratic formula. So you know what? What is the quadratic formula? It's completing the square. How did I get this? I did exactly the same steps we did on those previous problems. But what's the downside to the quadratic? It's like eating the hamburger in one big bite. There's just a lot of meat that goes into that thing, and sometimes it's tough to chew, so you can easily make some mistakes. So not wanting to beat that too much, let's take a look at one of those problems and see if you guys can actually remember how to do the quadratic. Do you guys remember how to do that? It's been a long time. This is the last little thing that I wanted to do with you guys for today. Make sure that we're all golden. By the way, this is a college class, so there's some things that I won't lecture over. You're just going to have to look at the textbook to see little things because I don't want to lecture super, super long, okay? Trying to avoid that. So what are we calling A? 2. What are we calling B? 7. And C is -5. Okay, so I want you guys to do the quadratic formula. And while you do the quadratic formula, I'm going to complete the square. And we'll race to see who does it faster. Done. Which method's good? Both. You get to choose which one you want, but here's the deal. For my class, I'm going to require you to do some problems by completing the square because it is a solution later on in our term. Back at the very early part of our term, I talked about some things that we're going to study in here. There's some things that we're going to study that the quadratic won't work on, but completing the square will work on. So I do need you to be familiar with that. So here's what I have for you right now. So we got about 9 minutes left to kind of go back and forth. Prereq number 3 that you guys have in front of you, right? So prereq number 3 just has you practice a couple of those skills. So the 2 things that you guys are working on is the little systems of equation game that I gave you, and then the prereq number 3. Now, I didn't talk about absolute values, but remember when you solve an absolute value, set one equation equal to the positive, set it also equal to the negative, and solve both of them independently, and that's how you do that, which I think you've done in previous classes, okay? So that's it. You have about 8 minutes to do a little bit of work. I'm going to walk around and help you guys, and I think that'll be enough for today, okay? And I'm going to go ahead and